Good evening, students. Again, I'm Shivan Gota Birada, PMRF PhD Fellow at Control and Automation Department, Department of Electrical Engineering at IIT Delhi. Today we'll be looking at assignment 4, which mainly concerns null spaces. This assignment would be mainly looking into null spaces and then spanning set, null spaces, row space of A transpose, then something about Wronskian matrix, then how the polynomials can be formulated as a matrix and how to find their solution, and diagonally dominant coefficient. Today's assignment is fairly easy. Let's start the assignment. So the question here is that the dimension of null space of A, which is an M cross N matrix, is equal to the dimension of null space of A transpose. Okay. So let us say that matrix A is an M cross N matrix, and the rank of matrix A is equal to R, which is less than or equal to minimum of M cross N. So obviously the dimension of range space of A is equal to rank of A, and the dimension of null space of A is equal to N minus R. So this results come from rank nullity theorem. Rank nullity theorem. Let us see what happens in A transpose. A transpose is an N cross N matrix, and again this is a very important result here. Rank of A transpose is equal to rank of A, which is equal to R. So no doubt that the dimension of range space of A transpose is equal to R, but the dimension of null space of A is equal to M minus R, because M are number of columns here. M is number of unknowns. M is number of unknowns. Here N is number of unknowns. So this result is again coming from rank nullity theorem. Rank nullity theorem. So what is actually this rank nullity theorem? Dimension of range space of any matrix, say B, plus dimension of null space of B is equal to the number of unknowns. Let us say that B belongs to R n cross M. Then the number of M and unknowns would be M. So this is the rank nullity theorem. So we are using this rank nullity theorem to get back to this result. So comparing this and this, we see that both are different. So obviously, then this is true, which means that the dimension of null space of A is not equal. Sorry, this is a non-square matrix. So dimension of null space of a non-square matrix is not equal to the dimension of null space of A transpose, non-square A transpose matrix. Let's move on to second question. What is the choice of matrix A such that the null space of A contains only zero vector? Okay. So the first very important point here is to check the rank of this matrix. Then to use the rank nullity theorem. So this itself would give us this answer. So let us take our first matrix, this matrix, and see whether the null space of this matrix contains only zero vector. So by calculation, the rank of this matrix would be 3. So remember, how do you get this, the rank of A? So first you have to get an RREF, that is row reduced echelon form corresponding to this matrix, which would be A tilde. And the number of non-zero rows would be the rank of A. So this is how you get the rank of A. Or you can directly use rank command in MATLAB. So this would give us 3. So which means that there are 3 independent or 3 non-zero rows in A tilde. And by rank analytic theorem, we see that the dimension of range space of A plus dimension of null space of A is equal to 3, because 3 is number of unknowns. 3 is number of unknowns. This is very important. And we see that dimension of range space of A is equal to rank of A. So 3 plus dimension null space of A equal to 3. Dimension of null space of A equal to 0, which means that the null space of A, where A is this matrix, is spanned by only 0 vector. So null space of A does contain only a 0 vector. This is an important result, and this is totally as a consequence of this result. Rank nullity theorem. Again, same procedure. First, you are given a matrix A. Find out the RREF, row reduced echelon form corresponding to matrix A. And this would be A tilde. Check how many rows are non-zero. So the number of non-zero rows would be rank of A. Then we see that this rank of A is equal to dimension of range space of A. Right? Then by using the rank nullity theorem, we get the dimension of null space of A. So this information would tell us whether there is only zero vector in the null space. So let us check this problem. So here we have 4 unknowns. Remember this. And by calculation we see that the rank of A is 2. Okay. By rank nullity theorem, we see that the dimension of range space of A is equal to 2. And from this equation, we get that the dimension of null space is equal to 2, which means that null space of A is spanned by 2 linearly independent vectors. So the null space of A does not contain only 0 vectors. It is spanned by x and y. Null space. So again, null space of A does not contain only 0 vector, but is spanned by this will be 2 linearly independent vectors. Another problem. I have a 3 cross 3 matrix here, and we know okay, this is not important, but let us stay here. First, we have to check the rank of A. We get that rank of A is equal to 2. From this, we get the dimension of range space of A, which is equal to 2. By rank nullity theorem, we see that the dimension of null space of A is equal to 1. So this means that null space of A does not contain only 0 vector, but is spanned by 1 vector. So let us move on to our third problem. Consider the given matrix A. So this is your matrix. Now the question is, what is the dimension of left null space of matrix A? So left null space, okay. So you have this matrix. So how do we define the null space of matrix A? Null space of matrix A is defined as set of all x belonging to R3 such that these x, when multiplied by A like this, results into a 0 vector. So we call this as a right null space. What about null space of A transpose? So this is null space of A transpose. Null space of A transpose is set of all y such that when A transpose is multiplied by this y, we get a 0. So we say this expression as a left null space. So this is simple. You have to check this. Like, we have to check the dimension of this null space of A transpose. Again, a very simple thing is we have to use the RREF, then calculate the dimension of range space, then calculate the dimension of the null space using rank nullity theorem. So the rank of A transpose is 3, which would be again equal to rank of A. And by rank nullity theorem, we see that dimension of null space of A transpose is equal to 0. So moving on to fourth question. Consider that you have a matrix A, which is given by this, and let S be a spanning set for the null space of A. Then which of the following are true? Again, this is a very simple problem here. First, you have to find the rank of A. So this you get by row reduced echelon form of A. After getting rank of A, you will know the dimension of null space of A. This we get by rank nullity theorem. Or even this is also not required actually. I'll tell you, like this is all not required. A very easy thing would be to calculate first RREF, then solve, then yeah. First form an RREF matrix, then see what are your pivot variables and what are your free variables. Okay. Then combine these two information, which means that you have to express the pivot variables, in terms of free variables. Then you'll get the answer. So you have a matrix A, which is given to you. You get this matrix A tilde after a row reduced echelon form. This is your row reduced echelon form. You apply various row operations and column operation to get this RREF form. You see that this is a rank. The rank of A is equal to 2, or A tilde is 2. And these two are your pivot. These two are your pivot. And you have to, the question says that this is the spanning set of, okay. So you have to find which of these is the spanning set of null space of A. So once you get this matrix, you calculate the null space of this. So for calculating the null space, remember null space of A is set of all x belonging to R4 such that AX is equal to 0. You do the same thing here. You use this here. These are your pivot, and corresponding to these pivot, these are your pivot variables x1 and x2. So x1 and x2 are your pivot variable, x3 and x4 are your free variables. From this, we get this expression x1 plus x3 equal to 0, x2 plus x3 equal to 0. So we know that x3 and x4 are free variable. Free variable means they can take any value in R. So x1 equal to x3. Let x3 be equal to alpha, and alpha belongs to any value on the real number. And x4 equal to beta, that can belong to any real number on real line. So once you write like this, so x1 would be equal to minus alpha. So x1 equal to minus alpha. x2 is again equal to minus alpha. x3 is equal to alpha. So x3 is equal to alpha. And x4 equal to beta. So the null space of A is spanned by two linearly independent vectors, which are given by these vectors. So from here also you can see that dimension of null space of A would be equal to 2. One more interesting thing here is that this can be written like this. Okay? If you simply multiply this vector by -1, you get this vector. And this remains the same. So, here both of this answer are true. So let us move on to fifth question. Consider two matrices A and B, okay? And we have to see which of these followings are true. Again, these are very simple questions. Null space, you have to calculate the null space, range space, and then null space of A transpose, range space of A transpose. We will look into this part at present. So we have A as this matrix, B as this matrix. So we have to calculate null space of A and null space of B. Very simple question. A tilde, B tilde, which you get by RREF. So these are your RREF form obtained by row operations. So again, these are your pivot. And corresponding to these pivots, x1 and x2 are your x1 and x2 are your pivot variable. Here x again x1 and x2 is pivot variable. X3 is your free variable. X3 is your free variable. X3 is your free variable. X2 x1 x2 are pivot variable. In this part, x1 x2 are pivot variable. X3 is also a free variable. So what we are doing here is that we have to express the pivot variable with respect to the free variables. Here we have to express the pivot variables with respect to the free variable. So we have to calculate the null space of A tilde, which is equal to the null space of A. So instead of calculating the null space of A, I can calculate the null space of A tilde. So for calculating null space of A tilde, you will have to get into this form. So solving this equation would give us two equations: x1 plus 3x3 equal to 0, x2 plus 2x3 equal to 0. Here x3 is your free variable, which means that this can take any value in the real number. So let us say that x3 is alpha, which belongs to real number. Real number. X1 equal to minus 3 alpha, x2 is equal to minus 2 alpha from these equations. And when you finally combine this, x1, x2, x3, you see that x1 equal to minus 3 alpha, x2 equal to minus 2 alpha, and x3 is your alpha. So this vector spans the null space of A. Again, in this part, we have to calculate the null space of B tilde. Again, we follow the same procedure and we get this vector. So obviously, these two vectors will not be same. Okay. So the null space of A is not equal to null space of B. So our second part is to see whether range space of A is not equal to range space of B. So we know that A tilde and B tilde are RREF of B matrix, which is given to us, and A tilde is RREF of matrix A. So from this, we get this is our pivot, this is our pivot. For B, this is our pivot, and this is our pivot. Right. So this is a very important point here. So this pivot is in first row, and this pivot is in second row. Right. So sorry, second row. So this this one corresponding to column 1 of A and column 2 of A. If we take these column 1 of A and column 2 of A corresponding to these pivots, and, and these two will span the range space of A. Okay, again the same thing. The pivot here is in column 1. Pivot here is in column 2. So the column 1 of B and column 2 of B, if we gather it together and write it like this, then these two vectors will span the range space of B. A very careful observation says that the range space of A is equal to range space of B. So this is also not true. Remember this part. This is a very important part. Identify where your pivot lies. and then corresponding to the index of your pivot, you have to go back and see the original matrix and take out that column, that indexed column, and conclude that it is spanned by the null space, spanned by those two vectors. Now, this part tells us to check whether the null space of A transpose is not equal to null space of B transpose. Again, so this is my A transpose, B transpose. These are my RREF forms. So the same procedure, there is nothing different. We can see that the null space of A transpose and null space of B transpose are equal. So this is also not true. We have to check whether range space of A transpose is not equal to range space of B transpose. A transpose is this, B transpose is this. The corresponding RREF are this. Same thing. The pivot is in first column, first row. Pivot is in second row. Corresponding to the index of these pivots, we go back and take this. This is second column. So take this second column and say that these two columns will span the range space of A transpose. Here, the pivot is in first row. Pivot is in second row. So corresponding to pivot 1, we take the column 1. Corresponding to pivot 2, we take column 2 and say that these two vectors, linearly independent vectors, spans the range space of B transpose. And observing both of these two vectors, we see that the range space of A transpose is not equal to range space of B transpose. So these are some of the very important concepts. Now moving on to sixth question. So let us. So in this question, we have n set of function S, which has n polynomials f1 to fn, and these are n minus 1 times differentiable. And one of the most important information given us to is that they have one common root. Okay, so using this information, we have to see that whether set S is linearly independent, set S is linearly dependent, or the determinant of Wronskian matrix is non-zero. So I hope you remember this. I have given a brief description of this Wronskian in my previous week 2 lecture, I think. So the simple thing is to check if you have n number of polynomials and want to check whether they are dependent or independent. The very standard procedure is to first form a Wronskian matrix, then check the determinant, and also if at that point the determinant is not equal to 0, you have to check like again the determinant would be a polynomial. You have to see whether that polynomial is 0 at some point. So if that is 0, then it will be dependent. If that is not equal to 0, then it will be independent. So since this is a Wronskian matrix, and an important information which is given to us is that all of these n polynomials, n set of functions or polynomials have one common root, and at that common root it will become 0, right? So the determinant would be equal to 0 at that one common root, and hence we say that S is linearly dependent because Wronskian would be 0 at that one common root. So S is linearly dependent. So our seventh question. So in seventh question we have a cubic polynomial, a third order polynomial that passes through 0, 0, 0.5y, 1, 3, 2, 2. And the coefficient of x cubed is 6. So we have to find the value of y here. This is a very simple question. So we assume that, or say we not assume, this is the standard form of cubic polynomial. And the information given here is that the coefficient of x cube is 6. And all of other coefficients are unknown to us. This is what we have to find. Sorry, so we have to find y here, right? So we have to find This one. So let us take this first point 0 0. Right. So this is your, so you have x equal to 0 and this would be your P3 of 0. So this is your P3 of 0, and if you put x equal to 0 here, you will get this. So from 0 0, you get d equal to 0. The second point is 0.5 comma y. So this is your P3 of x, and x is your 0.5. So P3 of x is given here, and 0.5 is substituted in x, and d is equal to 0. So we negate this. So after solving this, you get this polynomial where y is unknown, b is unknown, c is unknown. The third point is 1, 3. So this is your P3 of x, and x is equal to 1. So after substituting x equal to 1, we get this type of equation where b and c are unknown. The fourth point would be 2 comma 2, where P3 of x is 2, where x is taken as 2. When we substitute this, okay, these. This equation where again b and c are unknown to us. But our aim here is to find the y. So if you combine all of these equations, this equation, this equation, and this equation, you get a linear system of equations. So this can be written in a more convenient way like this. Once you solve this, you get these are very easy actually. B plus C equal to minus from this, and 4b plus 2c equal to minus 46. Solve this to get b and c, right? So when you solve this, you get c equal to 17, b equal to minus 20. And we use this b and c, to calculate y here. So this is the equation where b and c are known to us or we have calculated previously. Using this, we calculate y. So once you do all the arithmetic operation, you get y equal to 4.25. Yeah, so this question is a very simple question. I hope you will do. I'll not be explaining this part. Okay, so again, we have a non-square matrix A, like A belongs to R m cross n. And here it is said that the rows of A forms a linearly independent set, which means that rank of A is equal to m. So there are m linearly independent row vectors. So we say that this is full row rank. So you have rank of A as m. So let us not worry about this at this point of time. We also know that rank of A is equal to rank of A transpose is equal to m. So that is our aim here. Okay. So we have to see that which of the following are true. Let us see whether this is true or not at this point. Null space of A transpose. So A is m cross n matrix. So A transpose would be n cross m. M is number of unknowns. Unknowns. A transpose would be n cross m matrix. Remember that the rank of A transpose would remain as m. By rank nullity theorem, we see that the dimension of null space of A transpose is equal to 0. So which means that this is true. And what about this? Do you think this is also true? So this is a very simple question. The rank of A transpose is already given. And yeah, it's also true. So this will be your answer. So this finishes our assignment 4. Thank you for your time. Closing.